Okay, let's see how we can see what Lenz's law says, or derive Lenz's law for the case where the magnet is moving away from the loop. So when the magnet is moving away from the loop, the magnetic flux is still positive, because the magnetic field that's produced by this magnet is still pointing in the same direction it was before. It's still pointing in a direction such that the angle between dA and B is less than 90 degrees. So the magnetic flux itself, it's a positive quantity. But because the magnet is going down, it's going away from the loop, the magnetic flux is positive, but it's getting smaller as time goes on. So that means when you get the derivative of this quantity, it's going to be negative. And a negative of a negative is positive. So that means the right-hand side is positive. And so you have a flip in sign. Remember, the right-hand side was negative when the magnet was going upwards. When the magnet goes downwards, it's positive. So that means that ES is positive in this case. So that means, is E in the direction of ds or opposite ds? It means E is in the direction of ds. So that means the current is in this direction instead. And so that means that the magnetic field produced by this induced current is going to be actually the same direction as the original magnetic field. And so this is where the Lenz's law comes for this part, that the induced magnetic field due to the induced current, it's in a direction to prevent the magnetic flux from decreasing. So when this magnet is going downwards, the magnetic flux due to the original magnetic field of the permanent magnet is getting smaller. The magnetic flux is getting smaller. So the induced magnetic field wants to be in a direction to prevent it from getting smaller. It wants to maintain the magnetic field as it was before, as much as possible, to prevent the magnetic flux from getting smaller. That's how you can translate into words, in a wordy way, how you can translate the mathematics and make it into a word kind of instruction, a group of instructions that you can then call Lenz's law.